So welcome again. Today we are going to discuss about PN junction diode. As you can see here, this is a symbol of diode. It has two electrodes. That's why this is called diode. So one is anode and one is cathode. And there are many kind of diodes, and you can see there are so many symbols shown here. And we will discuss what is a diode, what is these properties of diode and how does it work, what are the applications, and then we will discuss gradually one by one and different kind of diodes. So first of all, diode is the simplest and most fundamental non-linear circuit element, and it's just like a resistor, but a resistor is a linear device because it follows the Ohm's law. So the relationship between voltage and current is linear, but in the diode it is non-linear. So we will see it, and its most common use is in the rectifiers for converting AC to DC. This is the physical structure of diode, how it looks like. So it's a combination of P-type semiconductor and N-type semiconductor. It's called a PN junction diode. So let us first discuss what is P-type semiconductor and N-type semiconductor. So as you know, there are two types of semiconductor. First one is intrinsic semiconductor, second is extrinsic semiconductor. Intrinsic semiconductors are pure semiconductors, which are there is no kind of doping in these semiconductors, like carbon, silicon and germanium. These have the these have the valency of 4. So these kind of atoms need 4 extra electrons to fulfill their valency, means outermost orbit. But in extrinsic semiconductors, we have two types of semiconductors in extrinsic, like P-type and N-type. So whereas in intrinsic semiconductor, the number of electrons are now equal to number of holes. Hole is a vacancy of electron. But in extrinsic semiconductor, the number of electron is not equal to number of hole, because an extra electron or an extra hole is contributed by the donor or acceptor atom. So what is a donor or acceptor? Let us understand it. In N-type semiconductor, it is formed by doping an pentavalent impurity atom in a intrinsic semiconductor. So if you dope an pentavalent, we will have an extra electron. And in P-type, we dope a trivalent impurity atom like boron in germanium or any kind of intrinsic semiconductor, so that we have a hole, we have a vacancy of electron. So ultimately, in N-type semiconductor, we have lots of electrons, and in P-type we have lots of holes. So these kind of extra charge carriers, if we talk electrons and holes as charge carriers, then the charge carriers are very high in N-type as well as in P-type. But in N-type we have the majority charge carriers are electrons, and in P-type majority charge carriers are holes. This is the basic structure, how these impurity atoms are doped, and how in the right side you can see the energy band diagram, where valence band and conduction band are shown. So the most important property of a diode is it acts like a valve, and it allows current flowing only in one direction and not in other direction. So it's a unidirectional device. And based on the application of voltage applied to this PN junction, we can say there can be two type of geometries of applying the voltage. One is forward bias and other is reverse bias. So forward bias, when P-type is connected to the positive terminal of the battery, then it is, and N-type is negative, then it is the forward bias. And when P-type is connected to negative terminal and N is positive, then it is called reverse bias. So diode acts like that in such a way that the current flows only in the forward biased action. So this is how, the geometry or the circuit of forward bias PN junction diode, where in P type we have only shown here the holes, which are the majority charge carriers, and in N type we have shown only the electrons, while in actual there will be some electrons as a minority carriers in P, and also in N type it will also have some very few minority charge carriers as holes. But we are only concerned with how the majority charge carriers work on the application of a bias or the voltage. So here P type is positively connected, so it is a forward bias, and on the application of bias current flows because positive holes will move from the P type to N type, and electrons will come from N type to P type. So the current flows through the circuit inside and outside. So this results in a very high current in the milliampere range. In reverse bias the condition is just opposite here, because the current flows only due to the minority charge carriers, because now the voltage or polarity is opposite, so holes will not move from P to N, and similarly electrons will not go from N to P. So the minority charge carriers in P, which are the electrons, will go from P to N, and so there will be very few amount of current which is in microampere range. So generally or ideally it is taken as 0. So we say that diode allows current only in the forward biased direction and not in the reverse biased direction. This is the property of diode which is used in all the applications. Now this is the symbol, and in forward bias and reverse bias ideally we are showing that how voltage is current is very high in forward bias, but in reverse bias it is just like 0. Or this is the very important plot between the IV current and voltage. Sometimes it is called IV characteristics. So this is for a practical diode, and this was for a ideal diode. It is for a practical diode. So we are showing here that how the current varies with the voltage. So when we apply, so first, because here we are showing positive as well as negative side. So positive, this one, if we focus here first, then this is for forward bias. So V means voltage is positive. So 0.7 volt until the 0.7 volt is reached, there is no current, because this is the potential barrier. And now after the 0.7 volt, this is for silicon, and silicon or germanium, I don't remember it, please check it. So after this potential barrier is overcome, then we have a sharp increase in the current in the forward bias. And so but also you see here that this is not linear. So this is it is non-linear. Okay, it is not linear like the Ohm's law. And in reverse bias, what happens? Reverse bias, because we have also already stated that there is only very few current in microampere range. So it remains very low until a breakdown voltage is reached. So we will discuss it later, what is the breakdown volt. But apart from the breakdown, if we are concerned only here, then this is very small current in the reverse bias, and ideally it is considered as 0. This is the diode equation. Current, how current depends on the voltage. I equal to Is e to the power V over nVt minus 1. So this depends on the current also, because generation of minority carriers or minority current depends on the temperature. These are different kind of diodes like PN junction diode, LED light emitting diode, photodiode, Jenner diode, PIN diode and Schottky diode, having different kind of applications. We will discuss it later. And these are the applications in half wave rectifier, full wave rectifier, bridge rectifier, clippers, clampers, etc. So far that's all, and we'll come in the next lecture. Thank you.